Oh, but we are recording now. So we're back on to some trigonometry with question 6. We're looking at show by calculation that the equation tan squared x minus 2 is 0, where x is measured in radians is a root between 1 and 1.1. Have you noticed what's happened with this? We've already done a trigonometry question. And we've had to use our calculator because it wasn't a nice trigonometry question. We had to do inverse sine of minus 2/3, if I remember correctly. And it was all about degrees. It was minus 180 to 180. And so now, a few questions later, we're on trigonometry again, and this time we have to be in radians. Now they have at least made it fairly clear. They've said x is measured in radians. But we've got to be alert to that, haven't we? That we need to be changing our calculator. Don't expect to just do everything in degrees or everything in radians. Almost anticipate that you will have to switch between degrees and radians at some point during a core 3 paper. So here we go. And also, kind of really keep in your mind, you're doing core 3 on Friday and then core 4 the following Tuesday? Something like that. You know, be really aware that if you're doing anything with sine or cos that involves any kind of calculus stuff, that must be in radians. So, you know, don't end core 3 with your exam in degrees, with your calculator in degrees, and then, you know, just kind of without checking go into core 4 with it. No, because you're going to be doing loads of work. Sorry, that's all. Right, ignore that. Right, anyway, we're going to do this. Show it has a root between 1.0 and 1.1. Well, a root, this is that whole sign change gives us a root thing, doesn't it? And I would probably want to write this quite formally. So I might say, if I were doing this, let f of x be this function, tan squared x minus 2. And so what I'm going to do is I'm going to say f of 1.0, if I sub 1.0 into that, then, I think I've got this written down, what I got for this somewhere, I came up with, actually I'm gonna make it really clear that I am actually subbing that value in, just to be really careful here, and really make it clear that I'm putting it in, just in case my calculator haven't switched to radians and I get a nonsense answer. At least I've shown that I knew what I was intending to do. And this gives me minus 0.5745. And if I do 1.1, so tan squared 1.1 minus 1.1 minus 2, that gives me 0.7603. And what I've got from that is I have a change of sign. I can't just leave it like this. I have to say I've got a change of sign. Therefore, there is a root between 1.0 and 1.1. And actually, if I'm being really strict about this, I should have said something else as well. I should say that the curve is also continuous between those things. So change of sign and continuous. Therefore, we've got a root between 1.0 and 1.1. And I think OCR are a little bit inconsistent about this, because I think there have been times where they've really cared whether you said it was continuous or not, and there have been times when they let it go. Last summer they didn't mind if you didn't put the word continuous in there, which pained me to give the mark every time somebody hadn't, but there we go. Okay, so that was that bit. And actually there's something about this, about the way that you can write this. You know, having done all this work over 2 years to get to this point of doing core 3, you know how I've written out kind of everything? Yeah, I've done this in real great detail. I've even put this line here where I'm showing myself putting the number into the equation. But actually, why not just take that few extra seconds to make sure that for the person marking it, it's absolutely clear that you know what you're doing when you do this. Make it as clear as you possibly can. Because at the end of 2 years of doing this, you don't want to risk losing a mark just because you've rushed it and you've missed a bit out. You know, really, really be careful. Make it as clear as you possibly can. Part 2 then. Use the iteration formula given there with a suitable starting value to find this root correct to 5 decimal places. So what is a suitable starting value? Well, the root is between 1 and 1.1. So let's use what the question is telling us and start with either of those values. So we'll go there. If you really want to start with 1.05, because that's halfway between them, and that's all right as well. But kind of the easiest way to do it is to start with either of those values, subbing it in. So we're going to say that x1 is 1. I'm going to start with 1.0. The function this time, x2 is the tan to the minus 1 of the square root of 2 plus 1.0. And again, look, I've written it out just to be really clear about what we're doing. And we all know this, don't we, how to do this on our calculator to get it to loop it around. Is everybody familiar with that? So on your calculator, you are, can I borrow a calculator? Right, so we're putting 1.0 into our calculator and pressing equals, which stores it as an answer. We're then doing inverse tan, and this is in radians, so thank you, inverse tan of the square root of 2 plus ants, and make sure that the answer is inside the square root along with the 2, and we've got that there. And then if we press equals, this gives us, well actually this gives us a third of pi, is that right? Yeah, it should be, shouldn't it? So that's that gives us that, but I'll write it as a decimal. That's 1.047. How many 5 decimal places? So that's not enough. Oh, right, I'm going to do that. I'm going to do that. I'm going to write 6. Because we're looking for the answer to 5 decimal places, so I'm going to write down 6 each time. And which is pretty much what they wanted. And so then if we press equals again, it just shoves that answer back into the formula and gives us our next iteration, which is 1.050571. And every time we press it, we now get a new answer, but don't get carried away and just repeatedly press it, because we need to write these down as we're going along. We're looking for it for 5 decimal places, so we're not there. We're not anywhere near yet, are we? 1.050826. Now looks like we're pretty happy to 4 decimal places now. 1.050827, and we've now had 2 that have agreed to 5 decimal places. So let's do one last one just to be really convinced. There we go, and I've now got the same answer to 6 decimal places twice running. So, not enough, not all the marks got yet. What we're saying here is the root, or x, equals 1.05083. And we actually need to do that thing of not just leaving our iteration hanging, but actually to finish it off by saying, so the root is at this point. So x equals 1.05083. There we go. And then, thank you very much. Then the question went on to say, deduce a root of the equation x squared 2x minus 2x minus 3 equals 0. So what's the link with this one? Well, what was it? 6 squared 2x minus 2x minus 3. Well, first thing we noticed, we've got a link here between x squared and tan squared, haven't we? So going back to our trig identities, we know that that one, if we divide through by cos squared, gives us 1 plus, that's not good, divide through by cos squared, so tan squared x plus 1 is sec squared x. So sec squared x is the same as 1 plus tan squared x. So actually this equation here is the same equation as 1 plus tan squared 2x minus 2x minus 3 is 0. Because the first bit was all about tan, wasn't it? So let's get it in terms of tan again. Which means that this equation actually says tan squared 2x minus 2x minus 2 is 0. And we notice, no coincidence, we notice that that is very similar to what we had up there. It's the same as that equation, but instead of x, we've got 2x. Now, when we had x, we had that was the solution to it. So that is the solution to it as 2x this time. Does that make sense? That if you sub that in the place of the 2x, then it solves it, it gives you an answer of 0. So x is a half of that, and you do that in the calculator and hopefully get 0.525 to 3 significant figures. There we go. That's our answer. If you did an iterative thing with this, then I think they gave you the marks. Yeah, I mean, it did say deduced, but if you kind of started again with it, then you got away with it, but really, I think you probably shouldn't have done it. Was it 2 or 3? Oh yeah, you only got 2. That's it. So if you started again with this, instead of doing it as a deduced thing, they gave you 2 out of 3. Right. And that's maths, I forgot.